In this lesson, we want to apply the method of the Lagrangian multipliers to optimize a function subject to a constraint. Hi there and welcome to the channel. I'm Ferguson here. Now, this function here, which we want to optimize, is called the objective function. And this function here is the constraint. So we have our objective function. Objective function is the function f of xy is equal to 4xy. Our constraint is the function x squared plus y squared is equal to 8. Notice we can write our constraint as x squared plus y squared minus 8 is equal to 0. So this is our constraint and this is our objective function. Now, in order to carry out this process of optimization, we need to go through the steps I've listed down below here. Step number 1, we're going to have to set up our Lagrangian L. The Lagrangian L is a function of x, y, and a parameter lambda, which I will explain in a minute. I will explain the Lagrangian and I will explain the parameter lambda. Secondly, we have to find the partial derivatives of our Lagrangian L with respect to x, the partial derivative of L with respect to y, the partial derivative of L with respect to lambda. Thirdly, we then equate these derivatives, these partial derivatives, to 0. And finally, in step number 4, we use those equations to find the values of x and y that optimize our function here. So let's go straight to step number 1, set up the Lagrangian. Now the Lagrangian, as I said, is a function L of x, y, and lambda, and it's equal to f of x, our function, f of xy, our function, minus our parameter lambda multiplied by the constraint. The parameter lambda is called the Lagrangian multiplier. That's why the process is called the method of the Lagrangian multipliers. So in our case, our Lagrangian is, remember, our f of xy is the function 4xy minus our Lagrangian multiplier multiplying our constraint, which is x squared plus y squared minus 8. We must always write our constraint in this form. We take everything to one side and the other side, the right-hand side, is left as 0. So now this whole setup here is what is called the Lagrangian. Now, step number 2, we need to find the partial derivatives of the Lagrangian with respect to x, y, and lambda. Now, what is partial L, partial x? Partial L, partial x is equal to, here it gives us 4y, and here it gives us 2x lambda. Remember, this is not a function of x. This is not a function of x. So we are only looking at lambda x squared, which when we differentiate it, it gives us 2x lambda. Now, partial L, partial y is equal to, again here, it gives us a 4x, and here, in a similar manner, it gives us a 2y lambda. Lastly, our partial L, partial lambda is equal to, it's this whole term here, which is the coefficient of lambda. So it's minus brackets x squared plus y squared minus 8. Okay. Now, in step number 3, we are required to equate these partial derivatives to 0. So we can say this is equal to 0, this is equal to 0, and this is also equal to 0. Let's give this equation some names. Let's call this one equation number 1, this one is equation number 2, this one equation number 3. Now, if you look at equation number 1, it says that 4y minus 2x lambda is equal to 0. So it follows that our lambda is equal to, when I take everything, when I take my 4y to the other side, or the 2x lambda to the other side, then divide by 2x to leave lambda on its own, I will remain with 2y over x. So lambda is equal to 2y over x. It's a simple manipulation there, isn't it? Now, similarly, in equation number 2, we get, this implies lambda is equal to 2x over y. Okay, then, now, what we have here is lambda is equal to 2y over x, and lambda is equal to 2x over y. So surely this means that this here is equal to that, because both of them are equal to lambda. So straight away we can say 2y over x is equal to 2x over y, meaning that y over x is equal to x over y, because the 2's cancel out, don't they? Right, let's go over to the other side. So what we ended up with here is y over x is equal to x over y. Cross multiplying, we get x squared is equal to y squared, from which we can conclude that y is equal to plus or minus x. Okay, so that's our value of y there. Now, we still have another equation to deal with. The x squared plus y squared minus 8 is equal to 0. So equation number 3, we can write it as, because we can get rid of the negative sign and write x squared plus y squared minus 8 is equal to 0. Now, we have discovered that y is equal to plus or minus x. So instead of y, we can write our x there to get, this implies that x squared plus x squared minus 8 is equal to 0. 2x squared minus 8 is equal to 0, from which we can conclude that x is equal to plus or minus 2. Now, let's remember y is equal to plus or minus x. So y is also minus or plus 2, isn't it? So we have 4 scenarios here. We have a scenario where x is equal to 2 and y is equal to 2. Another scenario is where x is equal to minus 2 and y is equal to plus 2. The third scenario is where x is equal to plus 2 and y is equal to minus 2. The fourth and last scenario is where x is equal to minus 2 and y is equal to minus 2. Now, in each of these scenarios, what is the value of our f of xy? Well, when x is 2 and y is 2, we have 4 times 2 times 2, which is a plus 16. So we have a plus 16 here for our f of xy. Second scenario, when x is minus 2, y is plus 2, we have 4 times minus 2, which is minus 8 times 2, which is a minus 16. Third scenario, x is 2, y is minus 2, 4 times plus 2 times minus 2, it's a minus 16. Lastly, we have a minus 2 and a minus 2, so that gives us 4 times minus 2 times minus 2, which is a plus 16. So there are two possible values for our f of x given these scenarios. One is a plus 16 and the other one is a minus 16. So we can conclude that the maximum for f of x, so maximum value will be equal to plus 16. And of course, the minimum value of f of xy is equal to minus 16. So there we are. The method of the Lagrangian multipliers is yielded our sought up after values, the minimum and the maximum, which is a plus 16 and a minus 16 respectively. That's the method of the Lagrangian multipliers for you there. Please, if you are new to the channel, do subscribe and press the like button. It keeps us going. Till we see you in our next video. Bye-bye and take care.